Okay, so we're looking at stairs and railings tonight. This tool is found on the architecture tab, so you can see the stair tool right here. So stairs in Revit come in three initial configurations. If you go to the stair tool and fire it up right now on the architecture tab, I will walk you through the three different kinds of stairs that Revit creates. Okay, with the stair tool activated, if you go over to the properties palette, you can see that there's these gray headings, and these are the three different kinds of stairs that Revit creates. The first one is the assembled stair. That would be a wood frame or a steel stair. The other two are cast in place or precast. And so here I'll do a set of each. So here's how it works. When you activate the stair tool, you choose what kind of a stair you're going to create first. So I'll create one of these assembled stairs. Revit has you in the Run tool. In the Properties palette, Revit starts from the level that you are on right now and builds a stair, or begins to set up the creation of a stair that would go to the next story up. So here you can see we're going from level 1 to level 2. And it figures out how many risers are needed. So we can do a set of stairs here, so you can see if I click at a point and drag across the screen, it's going to create a number of risers. If I go right to the end, it creates all the risers needed to get from level 1 to level 2. So that would be a straight run stair. Now I'll just undo that, and I'll use the Run tool again here. So using the Run tool with the straight run. And just a few things to point out here. You can choose your actual width of the stair. So if you want to make a 4-foot wide stair, you'd put in 4 foot first. Then you can choose the line that you draw. Does it represent the center or the edge of the stair? So I'll keep it at the center. So now I'm getting a 4-foot wide stair, and I'll draw half the risers that are needed. So it creates that one flight. And so each pair of clicks that you put on the screen will draw one flight of stairs. So there's click number 1, click number 2. Here's click number 3. Now I'm going to offset my next riser by 1 tread so that I don't get a gooseneck in my stairs, in the railing. So here's my second click. Keep going in a different direction, and you can see as I change the angle of my next flight that Revit's going to modify the shape of the landing to suit. So if I keep on going right to the end, I get all the risers that are needed, click, and I'm done. So Revit automatically creates landings between each one of these flights. So let me just illustrate again here. So I use the Run tool, create a few risers, say the 3 minimum required by the code. Then I can put in another few risers, and Revit creates the landing in between automatically. And then just making sure that my landing is as wide as my stair, as the code requires. Do the rest of the stairs. And there we go. So I've got several flights that together are making the stair that is required. Yes?
Sorry, if you exceed 18, does it continue going up to the next
Nope.
floor?
No, it does not. So, and that is because you've got your base and top level set to level 1 and level 2. If I needed to go a little bit higher than level 2, you know, if I need to go, say, 2 feet higher, that would also increase the number of risers that are needed. So I'd have to click on my uppermost flight, and there's a couple of drag handles here you folks need to be aware of. There is a circular drag handle which increases or decreases the number of risers in the entire stair. So here if I drag that circular handle out, 21 plus 1. So after the stair has been drawn, and you go back and click on the risers that you've created so far, the flights, not so much the landings, but the flights. The top and bottommost flights have round and triangular handles on them. Now, the round handle actually changes the number of risers that are in the stair total. Now, kind of an odd thing about how this works is that if you do need to change the number of risers in the stair, you can't do it using the lower flight. So what would I do if I wanted to make this lower flight 6 risers instead of 3? Well, then you could drag the triangular handle and it will subtract them from the other side. Oh, come on. There we go. So there you can see it's added some risers here and takes them from the other side. So let me actually make this a little easier just with a 2-flight stair. So I'll do 9 on the one side there and I'll do the rest on the other. So the reason Revit is drawing these extra risers is because I'm going to level 2 plus 2 feet. So Revit is dynamically changing the number of risers needed to satisfy the minimum requirements. So again, you cannot change the number of risers in the stair by dragging the dot, the round dot, on the lower flight. You have to do it on the upper flight. So there you can see that decreases it. And what's going to happen here, let's just have a look in the properties palette. As you are creating this stair, Revit is of course tallying the total number of risers that you've created so far, and it's also dynamically keeping track of the actual riser height. So based on the floor-to-floor height from level 1 to level 2 and 19 risers being in place, Revit is showing us the actual riser height. Now we've said that we've wanted 21 risers so far. If we can decrease this, and so far we're golden. Now if we keep decreasing the desired number of risers, now this can be at variance from the actual number of risers that are drawn. So here you can see if we say that we want 18 risers, Revit is saying, hey, you got an extra one. Now if I try to go down even lower, I'm still good, except actual riser height of stair is greater than the maximum riser height specified in a stair. Now we'll look at that in a minute. But your desired number of risers here, you can type that in yourself, and that is the goal for the number of risers that you want. So then over here, as you're putting in the number of risers by dragging this round dot, you can adjust the total number of risers in the stair. Now again, drag the triangular handle instead of the round handle on the upper flight, and you're going to add or remove risers from this flight, and you can see it gets added to the other side. So what happens if you drag that round dot on the first flight, the lower flight? Weird things. It starts at riser 3. So that means you'd actually have to take a big leap to get onto that first riser. So obviously, that's not working. So that's why I explained to you, don't use the round dot at the bottom of the stair. Just leave it where it is. And if you do need to change the number of risers in the stair, do it from the top of the stair. Now the other obvious question is, well, what if I want my stair to go in the opposite direction? So instead of this being the lowest riser, what if I want this to be the lowest riser? That's no problem. See the flip button up on the ribbon? That allows you to flip the direction of the stair. So while you are in sketch mode for the stair, where you're working on the design of the stair, you can use the flip button to make it go in the opposite direction. Now, as you are putting each of these bits and pieces in place, when you click on each flight, you'll notice that there is a temporary dimension here. So you can adjust the width of the stair in this way. You can also do it in the properties palette. So if I click on this stair here, I can go into the properties palette, 4 space 6, and now that changes the width of the stair. Now, need to change the width of my landing. So again, here you can see there's a temporary dimension that's put in place, 4 space 6. And now I can adjust my landing height to match my stairs, or my landing width rather. Once the different flights are in place, you can click on them and use the move command to move them around. So here, if I want to move this over for some reason. So often what will happen is you will have walls already drawn for your stairs to go into, and what you'll need to do is move your stairs into place so that the stringer is against the walls that you've already drawn. So here, let me just illustrate. I'll draw just a U-shaped set of walls here. So typically you'll have your stairway walls in place, and so when you're working on your stairs, you can just click on you could select the whole stair, and you could use the move command and move it into a corner. Might be your first step. And once you've got one side of the stair or two sides in the corner, then you can click on the other flight and move it so the outside edge of the stringer is against the wall, and Revit dynamically adjusts the landing for you at the same time. So once that's done, again, just drag the triangular handle to adjust the number of risers in that flight, and you are good to go. Now, if you do need to change the shape of the stair, I'm just wondering if I want to get into that now, whether I'll wait on the notes for that. I think that's what I will do. Now you'll notice that when I created that first flight and then the second flight, Revit auto-generated the landing. Now, if for whatever reason you happen to delete the landing, Revit has a landing tool. Click on that landing tool, and there's an auto mode here where you just pick one run and then the other, and then Revit auto generates or regenerates the landing between those two runs. Now, if you have a really significant floor-to-floor height with, say, 60 or 70 risers, and so I had a transit project I was working on, a Seattle monorail project, where we had basically 6 or 7 stories to get from the street up to the landing, or where the monorail was going to come in. So in that case here, let me just give you an example of what that would look like. So what I'm going to do here is just add a level. So you can see that's at 66 feet. So what I'm going to do now, architecture, stair tool, and so instead of making the top level level 2, I'm going up 66 feet. So I need 114 risers. So this is where things get a little bit weird, because you will be able to draw the stair on top of itself. And what I mean is, when I'm using the run tool, and you'd probably already have your stair tower drawn in place, draw a series of runs, come back to the other side, draw another series of runs, and then actually stack them on top of each other, just like I'm doing here. And if you really kind of want to see what's going on here, you can go into 3D, and before the stair is drawn, Revit gives you a little 3D preview of the stair that you've drawn so far. So this is even before you go to hit the green check mark to finish your work. So in 3D you can kind of get a sense for how the stair is going to wrap around. So go back to the plan view here, and I will carry on. So Revit keeps a running tally of how many risers you've created, so I'm up to 76 here. So I'll keep going with the run command, just keep stacking them up. And wow, that was amazing. So I've got an actual perfect increment of stairs that was required there. So once I'm done, I hit finish. So you'll notice that when a stair is completed, that Revit automatically adds railings to the sides of the stair. And we'll be talking about railings later on tonight. So this is an assembled stair. I'm just going to turn on shading here so we can see the stair a little bit better against the white background. So this is an assembled stair. It's got stringers on the sides, and it's got a tread and a riser. So you folks can see all of that stuff here on the screen. Stringers at the side, treads, and risers. So there are the two other kinds of stairs out of the box. There are the cast in place stair. So this is a concrete stair. So after you've created an assembled stair, you can swap it out and turn it into a cast concrete stair. And then, of course, we've got our final stair type here, the precast stair. The difference between a precast stair and a concrete stair is that the precast stair has little notches so that the one, like a run of stairs going up, would have a little notch so it can bear on top of a landing. With precast stairs, they all kind of bear one on another, and so using the precast stair type, it's still concrete, but you would have those notches made between the stairs and the landing so that you get those opportunities for the upper stairs to bear on a landing and the lower stairs to bear on a landing and so on. So there you can see the railings get created afterwards. Okay, so I'm going to switch this back to a component stair, and we're going to an assembled stair rather, and we're going to talk about some more of the properties of these stairs. Now, assembled stairs and component stairs in general are made up of a series of parts. So here, when we look at the type properties of this assembled stair, it's got a few different parts that comprise the stair's design. Just going to grab my markers here. So all stairs in Revit, they're called component stairs. Now this is a relatively new feature in Revit that came, I think Revit 2013 or so. And so with the component stair, you have these three different kinds. Assembled, so as we said, that is wood or steel. And then we have our concrete stairs, which is cast concrete and precast. Now we're going to look at the assembled stairs in a little bit more detail here. So other parts of these assembled stairs are what we call supports. And this can be a stringer or a carriage. Now we'll talk about the specifics of those in a few moments. Then we have the run. So that is the definition of treads and risers. And then we have addition for the landing construction, which is usually same as the run. So with these assembled stairs, you could have a stair definition that has 2 by 12 supports on the side, and then 1-inch plywood treads, and then a 1/2-inch plywood riser. Then you can turn around and make a duplicate of the same style, where it still has 2 by 12 stringers, but you're using a 2 by tread, like a 2 by 10 tread, with a 1/4-inch riser. So we'll dig into all of this stuff. So your landing, your run, your supports, these things here are all mixed into the recipe of an assembled stair. It's with the cast and precast stairs, there's no supports because these don't have stringers. It's just solid concrete from side to side. So the assembled stairs are a little bit more complicated than the cast and precast stairs. All of this stuff has, there's different folders inside the project browser in Revit where you can see all of these different bits and pieces, and these all contribute to the final definition of a wood frame or a steel stair. So for your treads, of course, you can define what kind of materials those are, whether it's a steel pan with concrete inside it, or a plywood tread, or a wood frame tread. Okay, so here I am inside the type properties of the out-of-the-box stair. So I just went to assembled stair and hit edit type. If you're wanting to follow along, you just merely need to either click on one of the stairs that you've got done, or go to the stair command again, and then immediately go to the properties palette and click edit type. So here we are. So you can see we have run type, landing type, whoops, wrong stair. So I need to be in the assembled stairs, 7-inch max riser with 11-inch tread. There we go, this is looking better. So in here you can define the rules of your stairs. So if you're using a Part 9 stair for doing residential construction, so I'm actually just going to duplicate this and I'll call it a Part 9 stair. So the maximum riser height in Part 9 for a single family residence is 200 millimeters. So I can put in 200 millimeters straight away and Revit spits out the imperial equivalent, 7 7/8 of an inch. Now, when Revit talks about the minimum tread depth here, don't confuse this with the actual tread depth on a real wood frame project. I'll show you why. Now, if we were to look at how the building code and how local construction practice, how we define a stair. So if we've got, 2 by 10 tread, and then we've got our riser behind it, we would call this whole distance here from that the foot sits on, that's what we would call the tread. And what we would call the run would be to the horizontal distance between two similar elements from one to the next. So that would be our run. So say from the front of the tread to the front of the next tread, that's our typical run. Now, Revit kind of messes this up a little bit. It's like Revit ignores the nosing distance. So here we've got this, of course, the nosing. So that's how the code looks at it. But this is how Revit looks at it instead. So what we would call run, or typical run, Revit calls that tread depth. So there's a little bit of a blurring of the, or maybe a mistake in the nomenclature here that Revit uses. So Revit defines the tread without the nosing length. So normally we would call that run, Revit calls that tread, and then it still calls the part at the front of the typical run, it still calls it a nosing, but Revit does not use the term run anywhere. It calls it tread instead. So be aware of that when you are defining your stairs. So whether you're using the assembled or the other stair types that Revit creates, tread in Revit means run to us in the architectural community. So when I go back to Revit and I talk about my minimum tread depth, the Part 9 allows for a 235 millimeter. And if you guys know your metric, you know that 235 millimeters is actually the same as a 2x10. It's a 9 1/4, so I can just put in your 9 1/4 inches. And that's my tread. So what I've got here now is I've got my maximum rise, minimum run for a Part 9 stair. So that stuff at the top here under calculation rules, this is all built into the stairs properties. Now, like I said, stairs use these runs and supports as part of the definition of the stair. Let's look at the run type. So if we were to go down into the project browser, so I'm just going to hit OK here, and I'm going to expand families, and I'm going to go down and expand stairs. And so there is the assembled stair list. Now this is an odd thing. I'll be talking about this in a few minutes. We'll get into it now, I guess. When you go into the stairs folder, Revit lists assembled stairs here, and precast stair, and cast in place stairs. So these three folders that you see here are different stair types that you would see in a drop down here. Now, inexplicably, at the same hierarchy, Revit lists all the other stuff that's used in stairs as well. So, these are stringers. Okay, see your stringers and carriages. Now, these are both used as supports on the edges of an assembled stair. So you've got your carriage supports and your stringer supports. And we have our non-monolithic run. So we've got our non-monolithic landing, non-monolithic run. So when they say non-monolithic, they mean framed. So if I go and expand non-monolithic run, see it says here 2-inch tread, 1-inch nosing, 1/4-inch riser. That is the same as I'm seeing right there. So this run type that you see here is the non-monolithic run as listed in the project browser. So this defines how the run is created inside of the stringers. So look at that first. Now, you'll notice that when I put my cursor in this field, there's a little ellipse button that shows up here. So you know the one that's got the 3 little dots on it. Now if you click on that, Revit spawns up the dialog box to define the run. So here's the new dialog for that. Now I wish to goodness that the designers of the software would make an actual piece of construction that matches what's out there. You can only get 2-inch treads if you go to a mill and you get it, made to a custom thickness. You can't buy 2-inch thick lumber from the lumberyard. So what I'm going to do is I'm going to duplicate this, And I'm going to call it a 2x10. 2x10 width, so use a W for width, and I'll use 3/8 ply. So now what I'm going to do after I've made this run definition that's called 2x10 with 3/8 ply is, of course, I'm going to change my tread thickness to 1.5 inches. Now this tread profile here, we don't get into that in this course. This is if you wanted to make a special shape for your tread. This is a profile family. It's listed in the profiles folder. You basically draw a black line that represents the cross-sectional shape of the tread. If you say default, it's rectangular. So most of the time your treads will be rectangular in shape. But if you wanted them to taper, to get thinner as it goes towards the nosing, then you'd use a profile family that defines the shape of the tread that tapers in the manner that you wish. Nosing length. So this tacks on nosing on top of the tread value. So back here, I'd have to go into edit type. Oh no, it's back here. So our minimum tread depth, our nosing length gets added on to the minimum tread depth as the nosing protruding beyond the riser. Now, this again uses a profile family, so it's a series of black lines in this family that gets loaded into your project that defines the shape that you want for the nosing. So if we're doing a wood frame stair, it's probably just going to be rectangular, so you can switch this to default as well. So default for tread profile, default for nosing profile, these will make for a rectangular tread, and then default just keeps the thickness of the tread and projects that out by whatever distance that you specify. So there's our treads all sorted out. So here for my riser, I said I wanted 3/8 ply. So I will put in 3/8 of an inch here, and that's it. So if I wanted to specify a tread material or a riser material, I could do so. So now what happens is that my Part 9 stair, instead of using that original sort of imaginary 2-inch tread definition, is now using a real world tread and riser thickness, that when I cut through my stairs and I do my maybe a detailed section on the construction of that stair, all the dimensions will be something that our contractor is going to find in the back of his truck or in the lumber yard. So that is the run. So it's pretty easy to define that. With the landing, when you click on it here and it pops up the dialog box for this, again it's just the same as the run. So it would be the same construction with whatever materials being used for the surface of the run and for whatever other construction is being done. So generally speaking, people just leave that as is. Now for the supports, we've got two different kinds of supports. We've got stringers and carriages. I think what we'll do here is we'll take a break. Let's come back at 7:33 now. We'll come back at 7:45 and we'll carry on.